Good evening and welcome back. In the previous video, we had discussed the construction of a galvanic cell and what it actually looks like. Today, we'll be discussing the working of the galvanic cell. Alright, let's begin. Now, in the galvanic cell, initially what I have is a strip of zinc, which is the anode. Now, this zinc metal, which is there, it slowly starts reacting with the electrolyte, which is zinc sulfate, or it starts reacting, and zinc slowly loses its 2 electrons to become zinc 2 positive, and those 2 electrons start going down in the solution. Again, understand with the illustration, zinc metal slowly starts losing its area, and slowly some amount of zinc comes out here in the electrolyte as zinc 2 positive. Now, zinc 2 positive will be balanced by the sulfate ions which are already present in the zinc sulfate. These are the sulfate ions, and this will be neutralized again to more amount of zinc sulfate. But what happens to the 2 electrons? The 2 electrons start flowing and flowing and flowing and flowing. From here, the 2 electrons are flowing and flowing till they reach here in the cathode. Now, in the cathode, the 2 electrons can go to 3 options are available. So, if I talk about the cathode, there are 3 options available in the cathode. Just take a look at this and then we'll be back to the diagram. In the cathode, we already have a strip of copper. Okay, this is a neutral strip of copper. I have copper ions in the electrolyte of copper sulfate. So, I'll write it like this, it will be better for you. I have copper sulfate solution as the electrolyte. This copper sulfate solution has copper ions and sulfate ions because the solution is made up of ions here. Okay, copper ions and sulfate ions. So, the 2 electrons which have come from the anode, the 2 electrons will be either going to the copper strip, or they will go to the copper 2 positive, or they will go to the sulfate 2 positive. 2 negative, I'm so sorry, 2 negative. Where do you think the 2 electrons would go best? As I can think, the 2 electrons would definitely go to copper 2 positive. Why is that so? This is because sulfate has already 2 electrons and it will repel 2 electrons coming up. Sulfate has a negative charge, negative will repel. Okay. If these 2 electrons go to copper, do you think there is anything called copper 2 negative? There isn't. But if these 2 electrons go to copper 2 positive, they can bring about this reaction. Copper 2 positive plus 2 electrons will give you copper metal, copper solid, and more copper will be generated here. So this reaction is possible. So what I can infer from this is, if I go back to this diagram, these 2 electrons go to the copper 2 positive here, and they bring about a reaction which will lead to generation of more copper solid, and what in turn happens is copper 2 positive is deposited as copper solid. Okay, but there is one thing, we will think that progressively this reaction will happen, and slowly the anode will become smaller, the zinc will become smaller, and the cathode, which is your copper, will become larger and larger. But actually this thing happens, but it actually cannot happen naturally. This is because once the zinc 2 positive will be lost, zinc will be lost as zinc 2 positive in the electrolyte in the anode. The electrolyte will become resistive to more zinc coming in, because there won't be more free sulfate molecules, the sulfate ions there to balance this zinc to zinc 2 positive. Okay, to zinc sulfate, I'm so sorry. Okay, there won't be more sulfate, so the solution will become neutral to accept the zinc 2 positive. So then how will the reaction occur? For that situation only, we are using the salt bridge. Then the function of the salt bridge comes. The salt bridge provides this inert salt in order to let the solutions conduct the zinc 2 positive here and let the reaction continue. So basically what I can say is the salt solution actually, the salt bridge actually prevents the accumulation of charges at both the ends and will allow the solution and the reactions to carry out. Okay, which gives me the 2 functions of the salt bridge, and as a result what I can see is the zinc, the anode will get smaller and smaller, it will get even smaller, and the cathode will grow in size in the copper following the reactions. What is my now the next important thing is, how do I get current here? I can see that electrons are continuously flowing from the zinc to copper, and zinc to copper. And we already know the direction of current is opposite to the direction of flow of electrons. So if the Electrons are flowing from the anode to cathode. Where is the current flowing? The current is flowing from cathode to anode, and this is your current, okay, which is also flowing here. And the voltmeter thus will show a deflection, because if there is a current, there will be the potential difference also. Okay, that's my conclusion. So I have generated electricity from a redox reaction, and hence my galvanic cell is working. Okay. Now in my next video, I will be discussing the reactions and representation of a galvanic cell in terms of chemical symbols. So till here we have just discussed the working. The reactions are upcoming in the next video. See the playlist for them as well. Until then, keep studying and like, share and subscribe my channel. Thank you.